Greetings. It's about time for us to learn a new data structure, and this will be the first data structure. You'll be using this in program number 1, so we should pay close attention to this. And the idea here is it's very simple. It's something that's called an ordered array. And the idea here is that if I have an ordered array, A, and let's just think about how this thing would work. Let's suppose we have a constructor, give it 10. So initially what that's going to mean is that we have this array that looks like this. Goes from 0 up to 9, and it's originally empty. But then I may come along and I may say something like a dot insert 23. And that should transform this thing into an array that looks like this. In the first slot, there's a 23. And it would be like that. But then if I come along and I say a dot insert 7, okay, remember the name of the thing that we're writing here is an ordered array. So what it should look like after that is there should be a 7 and there should be a 23. So what it's done is it somehow has maintained the order of the array. And if I came along from here, and I were to say a dot insert, I don't know why I keep doing this. If I were to say a dot insert 16, then what I would have is something that looks like this. So there would be a 7, and there would be a 16, and there would be a 23. So the idea is after each insertion, the array is still in order. Now, the naive would think that what you have to do is every time you add a new element to the array, you just have to resort it. But you should realize that that's not true. We spent a great deal of time at the beginning of class talking about this thing called the insertion loop. So that, for example, if I were to come along here now and I wanted to insert some new value, and suppose this was 10, that the way that I would do this is I would come over here and I would compare the 10 to the 23, and since 10 is less than 23, I would move this down to here. And then what would happen is I would compare the 10 to the 16, and that would move the 16 down to here. And then I would compare the 10 to the 7, and I would go, aha, here's where I need to put the value 10. And you recall we had this thing that we called the insertion loop that we used to accomplish that. And the nice thing about the insertion loop is it had a time complexity of just n, not n squared like a sort. And that is what we're going to use in this particular thing over here. So what's going to happen is we're going to start developing this piece by piece. So we're going to assume that there is a public class ordered array, and I'm going to assume a couple of things here. I'm going to assume that there is a private int n elms, and this is how many are currently in the array. So initially that will be 0. There's going to be a private int max size. That's how big the array is. And there's going to be a private int data. This is where we will store the data. And a couple of things here. We're going to have a couple of constructors here. So I'm going to have a public ordered array, and this is going to be my 0 parameter constructor. And what I'll do over here is I'll come over here and I'll say max size equals 10. I'm going to come over here and I'm going to say n elms equals 0. And I will come over here and I will say that data is equal to new int max size. I want to make a note here that for this particular example that we're working on, we're talking about an ordered array that is an ordered array of int. But we're going to see later on we could just as easily change this to other things. And in fact, you're going to have to do that in your first programming assignment. Now, the other constructor that I want to create here is one where I just provide it an actual parameter about how big to make the thing. So I'm coming in with a particular number. And I'm going to come over here and I'm going to say max size equals the size. Again, the number of elements is equal to 0. And I'm going to come over here and I'm going to say that data equals new int max size. And I'm going to close that up. So here are my two constructors right over here. The observant person may say, you know, you should create a copy constructor, and you're right, I should create a copy constructor, but I won't here. Your author didn't do it. That doesn't mean that it's okay, but I want to focus on other details of this thing. So the first thing I actually want to get into is this whole notion of inserting. And I'm going to come over here and I'm going to say public void insert, and I'm going to say int, and I'm going to call it new elem. And what I'm going to employ over here is I'm going to do exactly like we did before, and I'm going to use this insertion loop that we wrote before. And I'm going to come over here and I'm going to say for j equals, now remember we've got this variable called number of elements that's telling us how many elements there are in the array. So the thing to remember is if the number of elements is, say, 5, then that means that the valid indexes go from 0 to 4. So I'm going to come over here and I'm going to initialize j to n elems minus 1. And then I'm going to say, well, j is greater than or equal to 0, j minus minus. And then what I'm going to do is I'm going to come in here and I'm going to say if data of j is less than new elem, I'm going to jump out of the loop. Otherwise, what I'm going to do is I'm going to say let data of j plus 1 equal data of j. And this is all inside of the loop. And then you may recall what I need to do here is say data of j plus 1 is equal to the new element. And here's the most important thing in here. We've added an element to this array. I have to remember to come over here and increment this variable that's called n elms. So I'm going to come over here and I'm going to say n elms plus plus. Okay? So there are a couple of things I want you to note here. This loop that we've written right over here, this is the thing that we've been using for the past 2 weeks that we've called our insertion loop. We've already talked about it. This works even if the array is empty. This works if the new element that we have to insert is smaller than all the other elements in the array. It works if the new element to insert is larger than all the elements in the array. We've thoroughly looked at this. The nice thing about this is the complexity of insertion here is n. And what I would like you to do is take a look at the code that your author wrote in the book. I think it's crummy code. This is much, much better code, much, much more elegant, okay? And it's simple, okay? And remember the important thing over here, we have to increment the number of elements that are in the array. This is very important. And that's it. That's insert. Now we have other things that we have to talk about here. So let's come over here and give ourselves some more things to write. I want to talk about finding in the array. So there is going to be a public int find, and I'm going to come in here and I'm going to say int key. And here's the thing to remember about this. We're dealing with a sorted array. So if we want to find something in a sorted array, if you recall from class and you also recall from the video just previous to this one, we're going to use binary search. And we've already written the code for that. And we'll just repeat it here quickly. So we're going to have int high, low, mid. And what's going to happen over here is we're going to let low equal 0. And you know that high, in this case, is going to equal n elms minus 1. Okay, and now we come in here and we say while low is less than or equal to high. And now we have to go through the hokey pokey. So we come over here and we say mid is equal to low plus high divided by 2. And yes, I know I'm going rather fast, but I refer you back to the previous video. And now we're going to come over here and we're going to say if that's equal to key, then what we want to do is break. Then we want to say if data of mid is less than key, well then that remembers key. Remember, if data of mid is less than key, then key is in the right half of the thing. So what I want to do is I want to let low equal mid plus 1, else high is equal to mid minus 1. We're going to close this up. And then we have this if this is equal to key, we're going to use that immediate if, and I say return mid, semicolon minus 1, and I'm going to say return like that. Okay, and remember this has a complexity of log n. So far we've written insert, we've written find. Next, we want to write delete. And here's the way that delete should work. Suppose I have something that looks like this. Suppose this is an ordered array. And suppose I were to say something like a.delete 20. Well, the first thing I want to do, step 1, find 20. Okay. And what's going to happen is, so I'm going to be calling on my find routine. Okay, now find may return minus 1, in which case the thing I'm looking for wasn't found. Otherwise, it's going to turn where it found it. And once it returns where it's found it, what I want to do is I want to bump everything else up. So if it finds 20 here, then what I want to do is I want to transform that now into an array that looks like the following. There should be 10, and then I'm going to move 32 to where the 20 was. I'm going to move 45 to where the 32 was. I'm going to move 57 to where the 45 was. And here's the most important step. So I'm going to say find 20, then I'm going to shift. And then what I'm going to do is I'm going to decrement, most important step here, and elms. Okay? So I think delete should be a Boolean. And it returns true if I could delete it, and it returns false if I couldn't. So if I come over here and I say public Boolean delete int key. And what I'm going to do is I'm going to come in here and I'm going to say Boolean return value. I'm going to initialize that to false. I'm going to come in here and I'm going to say int where is equal to find key. Okay, and then I'm going to come in here and I'm going to say int j. And I'm going to say if where doesn't equal -1, okay, then what I am going to do, so remember, if it came back and it said 1 here, then what I want to do is I want to start the loop 1 past it. For j equals where plus 1. And remember, if I've got 1, 2, 3, 4, 5 elements, if n elms is 5, the last index is n elms -1. So I want j to start at where plus 1, And I want to say while j is less than or equal to n elms minus 1, I want to do j++. And what I want to do inside of this loop, okay, is remember I want to shift these down. So I want to say data of j minus 1 is equal to data of j. The other thing I want to do in here, if where doesn't equal minus 1, I want the return value to be true. I'm going to close that up. And then the last thing I need to do here, remember it's a Boolean, I just need to return the ret value. And I finish the whole thing up. That is delete. Finally, the very last one that your author includes here, it's very simple, just to output the whole data structure. I think he calls it display. No parameters. Int j, you might do something like the following. For j is equal to 0, while j is less than n elms, j++, and you could do something like the following. And that would be the end of that, and then that would be the end of the ordered array. Simple, right?